All right, guys, let's start with another example. All right, so make sure you guys have your guidelines written down. I'm going to write the next example here on this slide, but I'm going to continue adding more information to this page here. Okay, so next one I would like you guys to try is CO2, good old carbon dioxide. Okay, so go through steps 1 through 4, and then let's see what we get. Okay, so step number 1, I'm just going to use it, the space that I have on the left here. So just bear with me. All right, so we're going to work on CO2 on this. I just want to kind of be able to write on this page as well. Okay, so we'll do CO2 here. So first things first, you want to count the number of valence electrons. My pen is not working, so hold on. Okay, there we go. So first things first, we want to count the number of valence electrons. So carbon has 4, oxygen has 6, and there's 2 oxygens in this molecule. So we are at 2 times 6 is 12 plus 4, a total of 16 valence electrons. Okay, I hope everyone was able to get that. Next, we're going to build our framework. Now in the framework, I'm actually going to add a couple more points here. So in this case, remember the rule was that you want to always put hydrogen on the outer, as an outer atom, and carbon always wants to be a central atom. Okay, so that's your clue to build a framework for this molecule. Another clue to build a framework is that you want to put the more, we haven't really talked about this, but it'll be coming up towards the end of the current chapter that we're working on. So you want to put the more electronegative atom as an outer atom. Okay, and electronegativity is a trend that we have on the periodic table. I'm going to just very, very quickly mention that on this side. So electronegativity. And what this really means is that your atom wants, it has a desire for electrons around it. Okay, so there's a trend. So if we know that trend, we can actually figure out which atom is more electronegative than the next one. So the trend is the electronegativity increases moving up in a column on the periodic table. So I'll write the word increases here. And it increases going across a row on the periodic table. Okay, so the most electronegative atom is actually fluorine on the periodic table. And an exception to electronegativity is noble gases are not electronegative. Okay, so helium would not be the most electronegative atom because that is in the top right corner of the periodic table. So if you were to actually follow the arrows in terms of the trend, you would think that it would be helium, but that's not the case. Okay, so fluorine ends up being the most electronegative atom. Okay, so that's another thing that I wanted to add to the building of the framework. So if you look at the molecule I gave you now, CO2, carbon is to the left of oxygen. So oxygen is more towards the right and it's more closer to fluorine. So oxygen would be the more electronegative atom. And therefore you would place the oxygens on the outside of carbon. So carbon would still be the central atom. Okay, so let's build a framework on this one. So carbon in the middle. We're going to place 1 oxygen here, 1 oxygen there. Okay, so that's your framework. Step number 3 is to put in bonds between your atoms. So let's do that. 2 and 4. So we'll subtract 4 electrons. We're left with 12. Okay. Next thing is to basically to start putting in your lone pairs in order to complete the octet, starting with the outside atoms first. So we can see that the oxygens on both sides still only have 2 electrons each in the bond. So this still needs 6 electrons, right? So 2, 4, 6, 8, 10, 12. Well, we used up all 12 electrons. Okay, so we're going to go back and check to see if we've completed the octet. The oxygens look happy, but the carbon doesn't. Carbon only still has 4 electrons in its octet, and that's not true. So carbon definitely needs 8 electrons to complete its octet. So what are we going to do? We can, actually I'll just put a little sub-step here under 4, because we're still completing octets. So step number 4, you may need to make double or triple bonds in order to complete the octet. Okay, so what are we going to do? Well, let's take 1 lone pair from this oxygen and let's move it on this side, in the middle between the carbon and the oxygen. Okay, so what do we get here? We get, I'm just going to redraw this. So we get a double bond here. And then we are left with 2 lone pairs on the oxygen on the left. And then we have a single bond here. And then you can have this on the other side. Is the carbon happy still? Not really, right? So we still need to put another pair of electrons for that carbon. Well, how about we take another lone pair and put that in between the carbon and the oxygen. And you could do this with the carbon and the oxygen on the left-hand side too. There's nothing wrong with that. I just picked that one out of, I don't know, my hand just went there automatically. Okay, so you can totally do that. So what do we end up with? We end up with a triple bond between that one. And we basically, we had a pair electron bond here. I don't know why I did that. So we had taken this one and put it right there, okay? So now what I want to do is I want to erase that one, right? Because we took that one. Well, do we have an octet for all of our atoms now? Yes, we do, right? The oxygen on the left has a complete octet. The carbon has a complete octet, and the oxygen on the right has a complete octet too. So this is now a good Lewis structure. You are okay to leave this structure as is. The truth is, this is not the real structure of CO2. The real structure of CO2 is the following. Okay, it's a double bond between both oxygens and the carbon. And both oxygens end up with 2 lone pairs on them. Okay, I would accept either one of them just because you don't know the reasoning why this, the second structure that I drew is the real reason that we cover in 4A. But this will suffice, okay? As long as you get to the complete octets, I would be very happy with that. But the real structure is the one that has a check marks beside it for CO2, okay? So again, count the number of valence electrons, build a framework, start adding your electrons as bonds between the atoms, and then start completing your octets by using up all of your valence electrons. And if you've used up all your valence electrons and you still need to complete octets, start making your double or even triple bonds. Okay, so that's what we need to do. So I'll stop here and we will do more examples in the next video.